In this session, we will learn total order sorting. We know that each partition is sorted. Hence, the output of each reduce task is sorted. And it is sorted by the key. Remember that values are never sorted. It is only the keys that are sorted. But the keys are not sorted across all the reducers. Then how do we sort the data across all the reducers? There are two ways to do total order sorting. First way is to use a single reducer. If single reducer is used, then there will be only one partition, and by default that partition will be sorted. Hence the reduce output will be sorted. As a result, whole data will be sorted. But this approach is not recommended. If the input data size is very huge, then all the data will be handled by a single reducer. Hence, lot of time is taken to sort the input data. Also, parallelism is not achieved. Even though resources are available in the cluster, only one reducer will be loaded with all the data. As a result, the cluster is underutilized. Because of all these reasons, this approach is not recommended. Second way is to use multiple reducers with custom partitioner. If we use the default hash partitioner, then the data will be shuffled across all the reducers. And we don't want our data to be shuffled. We want our data to be sorted. This is where total order partitioner class comes into picture. It is a built-in class provided by MapReduce framework to do total order sorting across all the partitions. This class is derived from the base partitioner class. Let's take a simple example. Consider a file containing records from 1st January 2000 to 31st December 2014. Here date is the key. Now let's sort the dates using 5 reducers. Since there are 5 reducers, 5 partitions will be created. And these partitions must be created in such a way that all the dates in the first partition must be less than all the dates in the second partition. And all the dates in the second partition must be less than all the dates in the third partition. Similarly, all the dates in the fourth partition must be less than all the dates in the fifth partition. To create 5 such partitions, 4 random dates or keys are selected. Let the dates be 3rd November 2002, 10th December 2005, 5th January 2009, and 7th February 2012. All these dates are selected randomly. Using these dates, partition is created. All the dates from 1st January 2000 to 3rd November 2002 is sent to first partition. That is, all the dates less than or equal to the first key is sent to the first partition. Next, all the dates from 4th November 2002 to 10th December 2005 is sent to the second partition. That is, all the dates greater than the first key and less than or equal to the second key is sent to the second partition. Similarly, all the dates from 8th February 2012 to 31st December 2014 is sent to the last partition. That is, all the dates greater than the last key is sent to the last partition. In this way, using 4 random dates or random keys, all the dates are sorted across 5 partitions. That is, if we configure n reducers in our MapReduce program, then by selecting n-1 random keys, we can create n partitions, and all these partitions will be globally sorted. This is the logic behind total order sorting in MapReduce. Total order sorting is achieved using 2 jobs. First job will convert the file from any format to key value format. You can either use text output format or sequence file output format. Here we are using sequence file output format. That's because it is more compact and efficient. This job is a map-only job. It will just read the input records and emit keys and values. So the first job will output sequence files which contain data in the key value format. If the input file is already a sequence file, then this job is not required at all. In the second job, actual total order sorting is done. So this is where we must use total order partitioner class. But before sorting, n-1 random keys must be selected from the input data. How n-1 random keys are selected? N-1 random keys are selected using random sampler class. It is a MapReduce built-in class. This class requires that the input file must be in the key value format. That's the reason why input data is first converted to key value format in the first job. The random sampler selects n-1 keys and writes it to another file. This file is called partition file. Then the total order partitioner class uses this file to divide the map output into n partitions, such that records are sorted across all the n partitions. In this way, total order sorting is achieved using 2 jobs, out of which the first job is optional. Let's take a Stack Overflow example to demonstrate total order sorting. The problem given here is sort user data by last access date. Currently it is sorted by creation date. We need to sort it by last access date. By doing this analysis, you will come to know who are the active users and who are not so active users on the Stack Overflow website. For non-active users, you can probably send an email notification so that they can come back again to the site. This kind of analysis is done by most of the websites. We have already seen the user dataset, so let's go ahead and check the code now. Here is the driver code. We are providing input path, output path and the number of reducers as arguments to the main function. A partition file will be created by this name. It will contain randomly selected keys. Output of the first job is stored in this directory. Here is the first job that converts input data to sequence files. It is a map-only job. As a result, number of reduced tasks is set to 0. Output format of this job is set to sequence file output format. Let's see the mapper class of this job. Mapper class of this job is very simple. As usual, user record is parsed. last access date, user ID and display name fields are extracted. Last access date is converted into milliseconds and then it is set as the output key. User ID and display name of the user combined together is set as the value. As a result, input data is converted into a sequence file with last access date as the key and user ID and display name as the value. Let's go back to the driver code and see the second job. Only if the first job succeeds, the second job is created. Random sampler object is created here. This will select n-1 random keys and write it to the partition file. It will pick 10,000 records from the input data. And the probability of picking a record is 0.1. It means for every 10 records, there is a probability that a record will be picked. Finally, n-1 keys are selected from these 10,000 random records. Then these records are sorted and returned to the partition file. Next, the mapper class of the second job is set. Here the mapper class is very simple. We are just reading input keys and values and writing it as it is. We are not doing anything here. That's because everything is done in the total order partitioner class. So instead of writing a mapper class, we can use the default mapper class, which is also called as identity mapper. Next, the reducer class is set. Even the reducer class is very simple. It converts the last access date from milliseconds to human readable form. Next, total order partitioner class is set. Then the partition file is configured. This function call will create the partition file. Earlier we had defined the random sampler object. That object and the job object are passed as arguments to this function. Random sampler will pick 10,000 sample records as configured earlier. And from that samples, n-1 keys are selected. And finally these keys are returned to the partition file. Only after the partition file is created, second job is run. And the total order partitioner class of the second job uses this partition file to divide the map output into n partitions. And all these partitions will be sorted globally. Let's run this program on the Hadoop cluster and check the output. Let's run the jar file now. Number of reduced tasks is set to 5. We have already seen the user dataset. Its size is around 660 MB. So 6 input split will be created and hence 6 map tasks will be created. Two jobs are run here. First job is a map only job with 6 map tasks. Second job is a traditional MapReduce job with 6 map tasks and 5 reduce tasks. Let's check the output now. This folder contains output from the first job. Since there were 6 map tasks in the first job, 6 files are created. These are the sequence files. This is the partition file. It contains 4 selected keys. This is the final output directory. Since we had configured 5 reduce tasks, 5 output files are created. Even though there are a lot of users whose last access date is 2014, records are evenly distributed across all the reducers. All the output file size is around 20 MB. That is because of the random sampler. Let's check the first file. It should start from 2008. These are the users who did not log in the site since 2008. Let's check the last file. It should end with 2014. These users are the most active users on Stack Overflow website. That was all about total order sorting. Thank you for listening to this session.